Hi everybody, in this video today we're going to be talking about, again, some basics that you probably have learned before, but we're going to be using them so much in this class that it's worth taking some time to go over them. So one is distributing, and we're going to distribute with a monomial. We're also going to factor out a monomial and talk about how that works. And all of this is in the context of quadratics, that if we know these skills, then we can solve quadratics, graph quadratics, etc. Okay. Do you remember, I'm sure you do, that to multiply a monomial, you have to distribute it. And so whatever number is outside there, we're going to distribute it to everything that's inside. And so this should be an easy one for us. Ooh, except we have exponents. Let's talk about that. So our first term here is going to be a negative 12 m to the, m to the fifth times m to the fourth. I'm not going to do this every time, but I think it's going to help us to understand what these rules are. Okay, what's going on here is I have m to the fifth, here's 5 m's multiplied together, m to the fourth, here's 4 m's multiplied together. So altogether, if I multiply these out, how many m's do I have? I have 9 m's. So this is negative 12 m to the ninth. And I have another minus sign, and I have an 18 m to the, again, if I had 5 of them in a row and then 2 more, I would have 7 altogether. And then this is a positive 12m to the fifth. All right, so that's how we distribute a monomial, one number on the outside. This next example is another distribution problem. It just is two problems kind of put together. So let's do them one at a time. First, I'm going to multiply that p squared times both of those. So that's going to give me 5p to the fourth plus 2p squared. And then I have a minus sign, and then I have a 7p. There's a lot going on here. Okay, so for now, I'm going to put this one in parentheses. I'm going to put a minus. And now, one thing on this example is you can distribute to the left also. So like this one, the outside number was on the left, and we went to the right. You can go, starting with the right, and go to the left as well. So I'm going to put parentheses, and I'm going to have 7p squared minus 28p. Lastly, I do have a minus sign, and we do have this other rule, and some people talk about distributing the minus sign, which we do have to do, because it's kind of like that minus is like a negative 1. So really what we have is 5p to the fourth plus 2p squared minus 7p squared plus 28p, because I had to distribute that minus sign to both of those things. And once again, I look to see if I have any like terms, which I do. And in exponents, the ones that are like terms are the ones that have the same exponent. And that's how we know we combine them. If they don't have the same exponent, we don't combine them. All right, so we get this. We get a negative 5p squared and a plus 28p. So that was a distribution problem that had a lot going on. And you just have to remember to take it step by step. But don't forget any of your steps and take care of everything as you go. When we go the other way, so this is multiplying, we distribute. The opposite of distributing is factoring. And so when I talk about factoring, just think about distributing backwards, okay? So when we do this, we're going to look for what can be factored out. Well, what does that mean? What it means is there a number that we can divide everything by, like that would go into everything? So for instance, for this first example, I can see there's an x on both of these terms, so I can factor out an x. And I also know that 4 goes into 8 and 4 goes into 12, so it also can be factored out. So my GCF here is 4x. And if I factor that out, what that means is I'm dividing each of these by a 4x. And if I do that, then what do I have left? Well, what I have left here is 2x. And what I have left here is minus 3, but my x is gone. So we're looking for what's the GCF of the numbers and also what's the GCF of the variables. So we factor out that GCF and we get the remaining part of it over here, and this is example D. All right, what I want to do right now is have you pause the video here. Pause the video here and see if you can match the other pieces. All right, here are the answers that you should have come up with. D, A, E, B, C. I want to talk about them a little bit. Here, greatest common factor was 5x, so I went over here and I looked at it, and then I can also double check. So since they are opposites of each other, you can go double check it by like multiplying it out. Like you could have gone over here and just multiplied these and see which one it matches with. And so some people on your matching, that might have been the technique that you used. That's okay. But I also want you to be able to come up with that GCF. Okay, number 3 is E. Same thing. I looked and I saw I could factor out a GCF of 6x squared. And if I go over here and I double check it, then that does check out. Number 4, I do want to talk specifically about some things in number 4. And mainly, how did I get this x squared here? Well, the way I got that is I looked at my x values, and each of these x values has more than just an x. It has an x squared. And there's an x squared inside here, and there's an x squared inside here. And so I had to have that 5x squared. Now the y's, I wrote over one, but one of them is y to the third, y squared. So we are basically looking for the lowest exponent that's listed out. And so x squared was the lowest of the x's that was listed, and y was the lowest of the y's that was listed. And so you just have to be careful with your variables to make sure you're getting the correct number out here. And then again, I can go and check and see if they work out, and they do. And the last one, there was an x inside both of them, and so it's just a minus b, which is left over. Okay, so I just already talked about a lot of this already, but factoring reverses the multiplication process. Factoring is the opposite of distributing. So in order to get the factor out, the monomial, you have to look for the GCF. And like I said, you have to look for both the GCF of the numbers as well as the GCF of the variables. Okay, so let's look for a GCF here. I can see that there's a 5 that can come out of everything. Is there anything else? Like, could we factor out an x? We really couldn't, because that 25 does not have the x on it. So when I write this out as a factored out deal, I'm going to say 5 times 3x squared plus 2x plus 5. Now, that trinomial might be able to be factored, but maybe not, and we haven't learned that yet, so we're going to skip that next step, although I don't really think that can be factored out at all. All right, number 2, GCF. For my numbers, I can tell that 4 is a GCF. For my x's, I think it's just an x. My board is having a hard time keeping up. Okay, so x, no exponent. Why not? Because this one right here does not have an exponent on it. And then our y's, yep, we can go y to the what power? Well, this is a second, this is a third, this is a fourth, so y to the second is my GCF. And so when I factor this, I'm going to factor out a 4xy to the second, and I'm going to divide each of these terms by that. So if I divide this, it gets rid of the 4, and it brings down my x to x squared. Because if I need to write this out. Okay, we haven't really spent a lot of time talking about exponent rules. We will, but we kind of need to learn them along the way as well. If you have, in this case, I'm going to be dividing by my GCF. That's 4xy squared. 4 and 4 reduces down to 1. So there's a 1 there. We just don't show it. The x to the third over x, well, x to the third over x is like x times x times x, and then over x. And so once again, one of those guys is going to cancel and leave me just with x to the second. Same thing with y to the fourth over y to the second. If you can imagine, we have 4 y's over 2 y's. What's going to happen? Well, 2 of these are going to cancel out with 2 of those, and they're going to leave me with just a y to the second on the inside. All right, factor out the 4, that leaves me with a 3. Factor out an x, that brings it down one level, down to x to the first, or just x. Y to the third minus y to the second, again, y to the first, or just y. Then I have a minus sign, and I have 6, because 24 divided by 4 is 6. X's cancel out, and my y's, oh, they also cancel out. So that's done. Lastly, I don't know that we really need to spend this much time on this, which is why they're kind of stuck here on the end. We did a couple of these in our last video. that if you have x plus 5, it really means x plus 5 times x plus 5. We might have even done this exact same example. Or if you have 2x to the squared minus 3 times 2x squared minus 3. I'm going to do this one because it's a little bit more interesting. This one is so basic. I think you guys know that one. So this is going to be 4x to the fourth. My board is being super laggy. Okay, I changed my setup on my board, so hopefully this won't lag as much. So we were multiplying this. We got 4x to the fourth. And then we have a minus 6x squared and another minus 6x squared. And then a negative 3 and a negative 3 gives me plus 9. So now I have to go through and add my like terms, which the two middle ones are the only ones that have x squared. So those are the like terms. So that's minus 12x squared, and I still have my plus 9 on the end. Once again, I think we did one of these in the last video, so I'm not going to do that easy one with you. I'm going to do the more difficult one because that'll make that if you know how to do this one, you know how to do this one. So we'll do number 8. We're going to multiply these numbers together, which is going to give us 9x to the fourth minus 3x squared. And then the middle terms together are the 1 times both of those, which is going to give me a positive 3x squared and minus 1. So now once again, I'm going to add my like terms. So I have a negative 3x squared and a positive 3x squared. That adds up to 0. Adds up to 0, it's gone. So I still have my minus 1 on the end though. So 9x to the fourth minus 1 is my final answer here. Okay, so what did we learn in this lesson? One thing is we learned that factoring is the opposite of distributing. We also learned that when you multiply powers, you add the exponents, and when you divide powers, you subtract the exponents. That was not the whole gist of the lesson, but that was something, a little side note that we had to know in order to do what we've been doing. All right, all of this is going to help us to solving quadratic equations. Why do we need to solve quadratic equations? Because there's those times when we graph it and we can't see what the x-intercepts are. And this is going to tell us what are the x-intercepts. So just one more tool in our toolbox. All right, when we come to class tomorrow, we'll do some practice on this.